Okay, first of all, you need to recognize that this is an improper integral. As you can see, we don't see plus infinity or minus infinity, so we are only left if there is a point where the function inside this function here is infinite. Since we have something over something, most likely if there is any point where we have vertical asymptote or the function becomes infinity, it should be where the bottom is equal to 0. As you can see, this is only happening when x is equal to 0. So 0 is a bad point, and clearly if you take cosine of square root of 0 over square root of 0, you will find 1 over 0, knowing that square root of 0 is 0 and cosine of 0 is 1. So this will be plus minus infinity, and therefore 0 is a bad point with the vertical asymptote. Okay? So there are many ways you can tackle this. So this is truly an improper integral. Great. Now, there are many ways you can tackle these improper integrals. Either you go by the definition, meaning that 0 to pi squared over 4, 1 over square root of x, cosine square root of x dx equal limit when a goes to 0 plus from a to pi squared over 4, 1 over square root of x, cosine square root of x dx. So here, this definition will work as long as we know how to evaluate this integral. If the integral, this proper integral now, is extremely hard to evaluate, then we have to use the test of convergence. In this case, this integral is indeed easy to evaluate, and therefore what we'll do, we will evaluate the integral instead of using any test of convergence. In particular, we have the integral of 1 over square root of x cosine square root of x dx, and here we will use the substitution u equals square root of x, which gives us du equal 1 over 2 square root of x dx. Therefore, this is just cosine of u 2 du, because 1 over square root of x dx is equal to 2 du. And therefore, this is equal to 2 antiderivative of cosine of u du, and that is 2 sine of u plus c. And if we go back to x, we will find 2 sine of square root of x plus c. Therefore, the integral from a to pi squared over 4, 1 over square root of x cosine square root of x dx is equal to 2 sine square root of x between a and pi squared over 4. And this is equal to 2 square root of pi squared over 4, that's pi over 2, so that's sine of pi over 2, minus 2 sine of square root of a. Sine of pi over 2, that's sine of 90 degrees, that's 1. So the answer is 2 minus 2 sine square root of a. So the integral from 0 to pi squared over 4, 1 over square root of x cosine square root of x dx is a limit of 2 minus 2 sine of square root of a when a goes to 0 plus. Sine of square root of a when a goes to 0 will go to sine of square root of 0, and that's sine of 0, and that's 0. So 2 minus 2 sine of square root of 0, and that's sine of 0, and sine of 0 is 0. So the limit is 2, which is a number, so the limit exists. Since the limit exists, then the improper integral is convergent. Not only it's convergent, we do have also the value of the integral, of the improper integral. And this is something that tests of convergence will not give you.